Video is going to be on a classic type of problem where you're finding a shaded region. And it's a great polynomial problem because it combines a lot of skills in one problem-solving activity. So if I'm looking for an area, immediately that term area should trigger you to think you're going to be multiplying something. So if I'm looking for the area of the shaded region, I'm looking for the area of this whole rectangle without or after I've taken away the area of the smaller rectangle. So area of the whole, and if I think about taking away, that should trigger me thinking about subtracting the area of the smaller rectangle. Okay. And I like to just write those out in words sometimes before I get started, so I keep track of what I'm really thinking about here. Okay. So the area of the whole rectangle, the area of a rectangle is the length times the width, or the height times the width. And so I'm going to multiply this height here, this x plus 8, by the width, which is 2x plus 3. And then I'm going to subtract out the area of the smaller, and I'm just going to put some brackets around that. So I'm going to have I have this width here, which is x times x plus 4. Now, based on the order of operations, the second bracket is superfluous, but it's going to help me keep organized when I'm just thinking about my areas. Okay. So first I'm going to do the multiplication, and I guess I could do the multiplication inside the second parentheses, the second grouping symbols first. So I've got an x times x plus 4, which is going to give me x squared plus 4x. And then I can also do this multiplication up here. So I'm going to multiply this first term, x times 2x. So I'm going to multiply the x times 2x plus 3, which will give me x times 2x, which is 2x squared, and x times 3, which is 3x. And then I'm going to multiply the second term through that same polynomial. So I'll have positive 16x plus 24. Okay. I'm just going to clean up that 16x because I'm not going to read that correctly the next time. So plus 16x. Okay. So now I can do some addition and subtraction. So here I'm going to combine my like terms. So I have 2x squared plus 19x plus 24, and I'm going to subtract this entire area of the smaller rectangle, which means I'm going to subtract both of these terms, or I'm going to distribute this negative sign into the second polynomial. So when this negative 1 gets distributed to the x squared, so I have negative x squared, and then the negative gets distributed to the 4x, so I have minus 4x. Remember to pay very careful attention to signs when you have a subtraction in front of a polynomial. So then I can come through and combine any like terms, and if I take a look here, I've got an x squared term here and an x squared term here, and I've got an linear x term here and an x term here. So 2x squared minus x squared, well, that's 1x squared. So 2x squared minus 1x squared is x squared. Positive 19x, negative 4x combined is positive 15x plus 24. And that's my solution. Remember that you should be able to verify by selecting a number. So if I wanted to plug in something for x, maybe 2 or 3, some nice simple number, plug it in for x, find the area of the whole in terms of that value of x, find the area of the smaller in terms of that value of x, subtract it, you should get the same thing as if you plug in that value to this expression as your solution. I hope that helps with those classic types of problems.